Okay, hello everyone. Oh, wait a second. Yes, hello everyone. Welcome to part. I don't even know what part we are on now, but last time we did TryHackMe guided pen test. We have 11 views on this video. Awesome shit. Right, we used our own machine this time. And that was very easy to do, right? 11 views, that is great. We are making progress, I guess. But that's amazing. So हमारा अगला पार्ट आ चुका है जो है dive into pen testing. Learn the basics of penetration testing from methodology to responsible practice. We will get into this now and eventually हम पूरा course complete कर लेंगे. I know I'm very slow at the series अभी, but eventually we will pick up the pace. So let's do it. Yeah, it's a premium room. Great. We have introduction. Penetration testing is proactive security practice that helps organizations uncover weakness in their systems, application, and networks before attackers can exploit them. The value of a penetration test continues to increase as modern environments become more complex. Testers that understand the fundamentals of penetration testing can produce meaningful results and effectively communicate risk to stakeholders. This room introduces the core concepts that every aspiring penetration tester should be familiar with. It covers what penetration testing is and how it differs from malicious hacking, the areas of focus during penetration test, and the relationship between vulnerability, threat, and risk. It also explored why vulnerability exists in the first place, the mindset and habits that shape effective testers, and ethical principles that strengthen client relationship. Great. So it is simple. हम बस ये समझने वाले हैं malicious hacking और penetration testing में क्या फ़र्क है, जो कि वेरी ऑब्वियस बात है, बट ऑफ कोर्स ट्राई हैक मी हमको शुरू से oh my god I hate this. Yeah, so try hack me हमको of course बहुत okay, one more thing I want to clear out. I personally believe TryHackMe is um one of the best platforms to learn cybersecurity. If I search for TryHackMe, we will see some of these videos like stop using TryHackMe, right? I really don't believe that you should stop learning from somewhere. If I go TryHackMe, spelling is wrong but doesn't matter, and we check the pricing, it's literally, first of all, for free you can get a lot of free rooms to learn. So of course TryHackMe is great. Then there is also, oh, there's a max plan, very expensive, but all right. Full access to all the rooms, access to recent threats, persistent attack box. Persistent attack box, wow, that is new, that is crazy. So you basically have a server online, that is amazing. This is unlimited attack box. Yeah, but think about it, a normal individual would only need only need a premium plan, and from premium plan, just remember this pricing, 374 rupees. That is extremely cheap. For this much money, you can get wait, there's a yearly plan too. Yeah, this is the yearly plan, 374 rupees. So with 3 months free renewal. So for just 374 rupees per month, you are actually getting, if I go upgrade to premium, we have to buy, doesn't matter, but you are getting so much information, right? You get to learn so much. You have if you go into learn, for 374 rupees you get to learn pre-security, cyber security, security analyst, penetration tester, security engineer, AI pen testing, right? And not only that, you get to learn SOC level 1 and SOC level 2. And in penetration tester you get to learn PT1, and then you get to learn red teaming. And you also learn this is the different path. I think for this one you need to pay extra, because these are the cloud subscription. But हाँ, just 374 rupees के लिए तुम्हें इतना कुछ मिल रहा है. So I believe, and if we go to CPTS, If you go to CPTS pricing, right, this is fucking expensive, by the way. CPTS is great, but the learning resource is a different thing in CPTS, and the monthly, what do they say? The monthly subscription is a different thing in CPTS. So CPTS is great too, but if you are able to pay this much, only then. I cannot show it, Rabi. Maybe we'll make a separate video about it. But that is the thing. Do not stop using TryHackMe. TryHackMe teaches you a lot for such little amount of money that it's great. TryHackMe is great. So yeah, let's sorry for the rant. Let's dive into pen testing. Okay, so what are the learning objectives? Distinguish between penetration testing and malicious hacking based on the authorization, scope, coverage, and responsibility. Simple. Describe the core focus areas of web application and network penetration testing. Define vulnerability, threat, and risk, and apply the vulnerability x threat equals to risk. Relationship to evaluate real world scenarios. Okay, so what is the issue when vulnerability and threat mixes? We get a risk. Outline the 4 stages of risk management cycle and recognize when risks are mitigated, accepted, or transferred. Identify the common reasons why vulnerabilities exist, including human assumptions, software bugs, system complexity, over customization, and technical or design flaw. Great. Apply the mindset and habits of an effective penetration tester, such as attention to detail, contextual thinking, and avoiding tool over reliance or tunnel vision. Follow best practices during engagement, including maintaining good notes, collecting evidence, maintaining time, communicating proactively, and staying professional. Uphold the principles of ethics, permission, and trust throughout an engagement to protect both the organization and the tester. I know that was like a rant, but great. We have prerequisites for this. Introduction to offensive security. Have we completed this? We have not. We should complete this actually. But this room requires knowledge of security concepts. If you haven't done so, complete the following module before continuing. You know what? Let's do that. We will do that. This will be a huge video. It will be a big video, but we will do this. Introduction to offensive security. Understanding of offensive security entails and practice breaking into computer systems by exploiting applications. Start by learning the basics. Practice exploiting a vulnerability in online website. Investigator. Okay. This is simple. Let's go with web app, then operating, then network. So let's see web app security. Wow, it's a 90-minute room. This will be a big video. Then let me get ready for that actually. Where is the... What the hell? Okay, so web application security, WAP. It's vast. Every one of us uses different programs on our computers. Generally speaking, program runs on our computers using our computer's processing power and storage. Moreover, to use a program, we need to first install it. If we can use any program, what if we can use any program without installation? A web application is like a program that we can use without installation as long as we have modern standard browser such as Firefox, Safari, Chrome. Consequently, instead of installing every program you need, you only need to browse the related page. The following are some examples of web applications. Webmail, such as, oh, I've never heard for Tuta Nota. I've never heard for that. Proton Mail, Outlook, Gmail. Online offices suites such as Microsoft, yeah, you already know all these. Online shopping stores such as Amazon, Ali, Etsy. Thousands more examples provide my rate of service. Other examples include online banking, money transfer, weather forecast, and social media. Wow, this is really a huge one. The idea of web application is that it is a program running on a remote server. A server refers to computer system running continuously to serve the clients. In this case, the server will run a specific type of program that can be accessed by web browsers. Consider an online shopping application. The web application will read the data about the products and their details from database server. A database is used to store information in an organized way. Examples include information about products, customer, and invoices. A database service is responsible for many functions, including reading, searching, and writing to the database. The online shopping web application might need more than one database to access. For example, products database. This database contains details about the product such as name, images, specification, and price. Customer database. It contains all data related to customers such as name, address, email, and phone number. Passwords too. Sales database. We expect to see what other customer has purchased and how they paid in the database. We can already see the amount of information stored in any online shopping system. Suppose an attacker manages to exploit, hack the web application and steal the customer's database. In that case, this will lead to significant loss of the company and its customer. Of course. The image below shows searching for an item on an online shopping site. In the simplest version, this search will take 4 steps. The user enters a name, an item name, or related keywords in the search field. The web browser sends the keywords to the online shopping web application. The web application queries searches the products database for the submitted keywords. The product database returns the search results matching the provided keywords to the web application. Yeah, like this. The web application formats the results as friendly web page and return them to the user. Great. You search. It goes to the web app. Then the web app searches in the database. Database gives the search results back to the application. And then we see the search result in our computer locally. From the user's perspective, they will only access an elegant online shop where all the technical infrastructure is hidden. Ooh. Many companies offer bug bounty programs. A bug bounty program allows a company to offer a reward for anyone who's discovered a security vulnerability weakness in the company system. The main condition is that the found vulnerability is within the bug bounty scope and rules. Among many others, Google, Microsoft, and Facebook have bug bounty programs. Discovering a bug can earn you from a few thousand USD to tens of thousands of USD, depending on the severity of the vulnerability. The weakness you discovered. Okay, sure. Yeah, let me close this. Let's go. What do you need to access a web application? A browser. Yay, we were right. Okay, let's go with web application security risk. Let's say that you want to buy an item for an online shop. There's a certain function that you would expect to be able to do this web application. Most straightforwardly, the online order might go as follows. Log into the website, search for the product, add the product in the cart, specify shipping address, provide payment detail. Great. There are a few. Whoa, ho, ho. This is what I feel like, this is so huge, every time because I want to study this and I want to study this fast, right? With you guys, of course. So when I scroll down, this is not a premium room. When I scroll down, I see so much data and my mind is like, fuck this. Let's go into hacking. But that's the wrong way of doing things. You need to learn to do things, right? You need to know things. I have made that mistake in the past. And we are here to teach remote code execution. Couldn't find a better name, by the way. I loved doing this, but no more. And also this, but no one actually watched this video. I mean, yeah, 23 people watched it, but this is a great video, I believe. Yeah, so let's go back to the topic. There are a few main categories of common attacks against web application. Consider the following steps and related attacks. Log in at the website. The attacker can try to discover the password by trying many words. The attacker would use a long list of passwords with an automated tool to test them against the login page. Search for the product. The attacker can attempt to breach the system by adding specific characters and codes into search term. The attacker's objective is for the target system to return data. It should not execute a program. It should not. or execute a program it should not. Provide payment details. The attacker would check if the payment details are sent in clear text using weak encryption or using weak encryption. Encryption refers to making the data unreadable without knowing the secret key or password. We cannot cover everything, but we will present a few normal categories from OWASP top 10. Open Web Application Security Project is OWASP. Everyone should know that. Uh, don't worry if these techniques sound alien to you. TryHackMe walks you through each vulnerability. Each vulnerability. Identification and authentication failure. Identification refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove that the user is whom they claim to be. The online shop must confirm the user's identity and authenticate them before they can use the system. However, this step is prone to different types of weaknesses. Example weakness include allowing the attacker to use brute force, try many passwords, usually using automated tools to find valid login credentials. Great. Allowing the user to choose a weak password. A weak password is usually easy to guess. That happens lot of times. Storing the user's password in plain text. If the attacker manages to read the file containing the passwords, we don't want them to be able to learn the stored password, of course. There is the username, that's the password. Easy guessable password. I believe this is a great password. Beth. This is the great password. This is almost uncrackable. 1, 2, 3, 4, 5 capital letters randomly and a number. So of course they can also add a special character in this. Broken access control. Access control ensures that each user can only access files, documents, images, etc. related to their role or work. For example, you don't want someone in the marketing department to read the finance department's documents. Example vulnerabilities related to access control include failing to apply the principle of the least privilege and giving users more access permission than they need. For example, an online customer should be able to view the prices of the items, but they should not be able to change them. You should not have write permission. Being able to view or modify someone else's account by using the unique identifier, UUID. For example, you don't want one bank client to be able to view the transaction of another client. Being able to browse pages that require authentication, logging in as an unauthenticated user. For example, you cannot let anyone view the webmail before logging in. Oh, now we get into hacking. Injection. An injection attack refers to a vulnerability in the web application where the user can insert malicious code as part of their input. One causes this vulnerability in the lack of proper validation and sanitization of the user's input. Okay, cryptographic failures. This is rare though. Cryptographic failure is a rare one. This category refers to the failure related to cryptography. Cryptography focuses on the process of encryption and decryption of data. Encryption scrambles clear text into ciphertext, which should be gibberish to anyone who does not have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the ciphertext back into the original clear text using the secret key. Examples of cryptographic failures include sending sensitive data in clear text, for example, using HTTP instead of HTTPS. HTTP is a protocol used to access the web, while HTTPS is the secure version of HTTP. Others can read everything you send over HTTP, but no HTTPS. Not HTTPS. This is very true. This is actually too fucking true. It is so true that, oh, sorry for abuse. This is actually so true that I have tried literally everything in the book to read HTTPS traffic, and I just can't. But it is possible to manipulate HTTPS traffic. We'll talk about that sometime. Relying on a weak cryptographic algorithm. One old cryptographic algorithm is to shift each letter by 1. For instance, TryHackMe becomes this. We have just shift each letter by 1. So we have just shifted one letter. Yeah, you have to open the ABCD for this, because doing this from mind is too slow. This cryptographic algorithm is trivial to break. Using default or weak keys for cryptographic functions, it won't be challenging to break the encryption that use 1, 2, 3, 4 as the secret key. Yes, because this will take like literally 1 second to break. no matter how good the cryptographic function was. Don't worry if these techniques look challenging or sophisticated at first. TryHackMe has dedicated in-depth room to help you understand and experiment with various attacks against web applications. You discovered that login page allows an unlimited number of logins attempt without trying to slow down the user or log the account. Which category of security risk is this? This is, of course, authentication failure, right? Because they can just do the brute force attack continuously like this. So is the answer identification or authentication failures? I don't think so, but it is. Lol. Okay. You introduced that the username and password are sent in clear text without encryption. Which category of security is this? This is, of course, cryptographic failures, because we were just talking about HTTP and encryption, but there is no encryption, so it is a cryptographic failure. Practical example of web app security. Okay, let's do this. This is gonna be hard. This task will investigate a vulnerable website that uses insecure direct object reference (IDOR). IDOR falls under category of broken access control. Broken access control means an attacker can access the information or perform actions not intended for them. Consider this case where a web server receives user supplied input to retrieve objects like file data, documents, and they are numbered sequentially. Let's say that the user has permission to access photo named image this. We might guess that there are also image this and this. However, the web application should not provide us with that image even if we figured out its name. In general, an IDOR vulnerability can occur if too much trust has been placed on the input data. In other words, web application does not validate whether the user has permission to access the requested object. Just providing the correct URL for a user or product does not necessarily mean the user should be able to access that URL. For instance, consider this product page, right? Store TryHackMe product question mark ID equal to 52. We can expect this URL to provide details about product number 52 in the database. Items would be assigned numbers sequentially. The attacker could try other numbers such as 51, 53 instead of 52. This might reveal other retired or unreleased products if the web application is vulnerable. Let's consider a more critical example where the user ID is given. Would return the user with the ID 16 again. We expect the users to have sequential ID numbers. The attacker could try another number, possibly access other user accounts. This vulnerability might work with sequential files. For instance, if the attacker sees 007.txt, the attacker might try other numbers such as 001 or 006 and 008. Similarly, if you were ID number 16 and ID number 17 was another user, by changing the ID to 17, you could see sensitive data that belongs to another user. Likewise, they can change the ID to 16 and see sensitive data that belongs to you. Of course, we assume that the system is vulnerable to IDOR. Insecure direct object reference. Click the view side, let's see it in action. You will see a page showing inventory management system. If you click on the pinned shipment tab, you will discover an attacker has managed to mess things up as part of sabotage plans. Notice how they send the wrong tries to each assembly line. For instance, they assign scooter tires and motorcycle tires to bike assembly. I left unfixed. All the tires will go to the wrong assembly. We will hack the system back and undo the attacker step. On your activity, you can see the activity one of the users. We have reason to believe that this website has an IDOR vulnerability. Check the other users to discover which account was used to make malicious changes and revert them. After reverting the changes, what is the flag you have received? So let's give this a shot. Inventory management system manages all the shipment related to the tires. A competitor sent a group of malicious actors to sabotage our logistics. The attacker used the account of one of the employees, mixed up the planned shipments. If incorrect shipments are sent, the production will be delayed. Okay, so we have planned shipments, your activity, no recent activity by Roddy. We have inventory, we have planned shipments. So bike, sports, of course. Motorcycle, we have sent racing scooter tires and mountain bike tires. That is obviously wrong. So let's get into your activity and let's try to change this number to 1. Oh, he's president of this company, employee number 1. That's crazy. 2. vice president 3, executive assistant 4, 4, user not found 5, user not found 6, user not found 7, wait 7, okay, front desk 8, database administrator crazy 9, ooh, okay, so 9, Alia, database administrator. So the hackers used her account to change the inventory SKU 5522. If we go to plan shipments and we look for 5, the was 8, I think it was 9, 15 has changed, so this is the one that is wrong. And which else? 15 and 257. Let's see if Alia is the one who has changed it. 257 and 15, we have reverted them. 257 and 15, yes. 9, 257, I did it. But now what to do? Wait, am I supposed to revert all of them? Okay, yep. Okay, Alia fixed the inventory management system. I do our explode. Great, we have the flag. And we have successfully done the room. Great, awesome. Hell yeah. Yeah, but we still have to cover the rest of the offensive security, operating system and network, which are my favorite. Web app I kind of don't like because I'm kind of bad at it, but these are very simpler to me. But because the video has gotten too long, right, 26 minutes is good enough. We will cover this in next video. Thanks for watching.